Greetings. We're going to take a look again at what we talked about in class last Monday. We're going to talk about elimination. Let me get my pen working here. Elimination, oops, can't even smell, of unit productions I just want to try to improve upon what we talked about in class last time. Remember what a unit production is. A unit production is something that looks like this. Um, you could even have, it may be the case that it looks like this. This, of course, is just really silly, and we get no useful information out of that. But you may remember way back at the beginning of this chapter, we did look at what was called the replacement theorem. I don't think we called it a theorem. We had something, if we said that, if we had a production that looked like this, okay, and the assumption here is that A doesn't equal B. We said that what we could do is we could get rid of this B and just substitute these expressions in here. You'll also recall that we said that even though these are lowercase, don't be misled into thinking that these things are necessarily terminals. They could be variables, but basically we could take this thing over here and we could rewrite A as given this. You could have x1, y1, x2. We've replaced this y1, or x1, y2, x2, or, and we can take this all the way down to the end, x1, y sub n, x2. That we could replace this production for A with this production for A, okay? Now, in the example of unit productions here, you would almost think that it's the same thing. In this case, it would seem that if you were to just let x1 and x2 both be lambda, it would be the same thing, and you could just employ the same rule. That is almost true. As your author points out, you could have a problem like this. You could have A implies B, and then you might also have B implies A. And if we were to go ahead and apply this rule with the B over here with what B implies A, this would come along and we would get that A implies A, which unfortunately is still a unit production and really hasn't helped us. What we are going to do is we are going to come back and use this replacement theorem that we used over here, but we have to do a little legwork first, and the legwork is really not that complicated. Okay, so let us move along here. Now remember, a lot of these, in fact, everything that we looked at in this chapter, it started off like the following. It said we're given G, a grammar, which is equal to a bunch of variables, terminals, a start state, and production, and we want to eliminate something. And that something could be something, it could be lambda things, it could be unit things like that. And ultimately what we did is we came down to here. We started with this original grammar and we came up with a new grammar, which we'll call G hat. And we said that that was equal to some V hat, comma T hat, comma S hat, like that. And the claim was that the original language was equal to the language that was generated by this new grammar. And in fact, we somehow built up this new grammar by somehow just changing some of the things in here, okay? So let us remember that our goal here now is that we want to eliminate these unit productions. So what we do is the first thing we do is we start off with v hat here. Actually, let's start off this way. We start off with p hat. Let that be empty. And then what we want to do is we want to add to p hat all productions in P that aren't unit productions. Now I've taken the liberty of doing this already. Let me see if I can get to it. It's over here. And this is the example that's from the book. Okay, so if you take a look at the original grammar right over here, we can see the S is given capital A, lowercase a, or B. Well, that S is given B, that's a unit production. So we get rid of that and we come down here and we have a restatement of what S is. Notice we've eliminated the unit production. Likewise, when we come over to here, we have that B is given by capital A or lowercase bb. The B given A, of course, is a unit production, so we get rid of that, but we still have in there B is given the little bb right over there. And now we come over here and we have A is given by lowercase a or BC or capital B. The A implies B is a unit production, so we get rid of that, but that still leaves us over here with A or BC. So first of all, this is what P hat looks like at this point right over here. Now at this point, we can almost do like we did before in the sense that we can do these replacements like we did over here in the single one, but now we have to worry about the fact that things could be bigger. And specifically what we're looking at now, remember before we were looking at things like we said, well, A to B. But now we want to consider the case, again, if we go back to the grammar over here, you can see that S can get us to B, B can get us to A. So again, this is going back to our notion before where we talked about the transitive closure of S. And when we do that, what we basically need to do is we need to build a transition graph. Okay, basically what we need to look at is the transitive closure of the grammar S. In other words, what we want to do is we want to consider not only unit productions like S might get us to T, but then we might say, suppose T gets us to U. So what we would say here is that S gets us in a finite number of steps to U. In other words, S and U is in the transitive closure of S. So what I need to do is make this dependency graph. I said transition here, it should be dependency. Okay, and if I go back to the example of the grammar that we had before, if we look at the dependency graph over here, the dependency graph is, well, S can go to B, so I start over here at S, and S can go to B, and then B can go to A, okay, and A can go to B. So what this means is that I can go from S to B, I can go from S to A in a finite number of steps, okay? I can go from A to B, and I can go from B to A. Okay, so what I need to do now is I need to use the replacement theory on these transitions here, the replacement theory, the replacement theorem being this theorem here, but now I take my transitions and my replacements from this grammar down here, not the original grammar. Remember, these are the productions that are in P hat. And what's nice about that is that these all by definition are non-unit productions. Okay, so I come over here, and originally I have over here, so I have S is given by AA, but now I have that S can also derive B. So that means I've got this over here, so I can put this here. I've also got that S can derive A star, so that's going to give me an A or a BC. Okay, and those would be all the productions I would have for S. Now if I come over here, originally I had B could derive BB, but I also have from the graph over here that from B I can get to A, okay, and A can also derive an A or a BC. I come over here to this over here, and I have that A can derive A or BC, but I also know from A I can get to B, so that means I also can derive a BB. And that would be my new grammar here, where I have gotten rid of all the unit productions. So again, to reiterate what the steps are over here, we want to use this replacement thing, but we need to do a little bit of work first. So the first thing that we need to do is we create a new set of productions, this P hat over here, and these have all of the productions from the original P that aren't unit productions. Again, going back to the example here, we started off with this grammar right here. I'm going to change the color of my pen. We started here, and we added to P hat just the productions that weren't unit. So that's not a unit production, okay? B equals A is a unit production, but B with BB isn't a unit production. And then A with A and BC isn't a unit production. So here are our non-unit productions in P prime. Then what we do is we calculate, okay, this graph over here, this dependency graph, and that dependency graph gives us these possibilities of where I can get to. From S I can go to B or A, from A I can go to B, from B I can go to A. And now what I do is I do apply this theorem again over here, but I do it in the following way. I'm going to apply it to these unit productions, but I'm only going to replace from this P hat over here, where these are non-unit productions. So when I go ahead and do these over here and apply it with these over here, I end up with my final grammar, which is this one right over here. I hope that's a little bit better than how we explained it on Monday. Okay, doing some of the problems will definitely help.